Okay, so now we're still working on geometric sequences, and we want to find what term number 81 over 16 is, or in other words, how many terms there are in this particular geometric sequence. So we're going to be using the general term formula, which is an equals a times r to the power of n minus 1. And we already know a bunch of elements. The last term here, 81 over 16, is just an, the last term. A is the first term, which is 4 over 9. So 4 over 9. And what about r? What is r? To find out r, I can just take the 2 over 3 and divide it by the previous term, which is 4 over 9. Great. So I can just basically flip the second fraction, multiply it. So here we have 2 times 9 over 3 times 4. 9 over 3 is just 3. 2 over 4 is just half, so I can put a 2 down at the bottom. So that's just equal to 3 over 2, and that is our r. R is 3 over 2. Fantastic. Now I can plug in, actually, I wrote 2 over 3, but I meant 3 over 2. Sorry about that. Big mistake there. And now we want to solve for n, right? So what I'm going to do, first step will be to multiply both sides of the equation by 9 over 4. That way, we're going to be getting rid of this fraction right here. 9 over 9, 1, 4 over 4, 1. Fantastic. So here we have 9 times 81, all over 4 times 16. And that's equal to 3 over 2 to the power of n minus 1. Of course, I could solve this with logs, but I won't. Instead, I'm just going to be manipulating these numbers and writing them as powers of 3 and 2. So, for example, 9 is just 3 squared. 81 is 3 to the 4. Down below, I want powers of 2. And I'm doing this just so I can compare these two sides and solve for n a little bit quicker. So 4 is just 2 squared. 16 is 2 to the power of 4. Right? And that's equal to 3 over 2 to the power of n. 1 second. Here we go. N minus 1. Great. So now what's going to happen here? I can combine the 3's, right? If I'm multiplying them, I can add the exponents. So over on the left-hand side of the equation, I get 3 to the power of 6. And can do the same with the 2's. 2 plus 4 is 6. And that's equal to 3 over 2 to the power of n minus 1. So note that I can actually bring the 6 just outside of the bracket here. I just made up these brackets surrounding the 3 over 2, right? And just brought the 6 outside since it affects the both of them. Hopefully that makes good sense to everyone. And now look at this. We have the same base, which is 3 over 2. So that must mean that 6 is equal to n minus 1, since 3 over 2 is equal to 3 over 2. So 6 equals n minus 1, so I can just add 1 to both sides of the equation. And 6 plus 1 is 7. So this is the 7th term of this geometric sequence, and that's what we wanted to find out. So we're done.